In this video, we'll talk about graphing the derivative function and how we can use properties of the original graph to tell us what the derivative graph should look like. So we know that at every point, the derivative function gives us the slope of the tangent line to the graph of the original function. So what does that tell us about this derivative if we were to plot out that function instead of the original one? If I have a positive slope, that means my graph has something of a trend in this direction going on here, because at every point the tangent lines here have a positive slope. The positive slope corresponds to having the derivative being a positive value, but if you look at the graph here, this is basically the same thing as the function itself increasing as you go to the right. So I can sort of go backwards here and say, well, wherever my function is increasing, that means my derivative graph should be positive. And the same goes the other way around. If I have a negative slope, that in general means that my graph itself is going to be decreasing because it's going to go down as I go to the right. And since it's negative slope, my f prime is also negative. As a third component, how could I locate places where f prime is 0? Well, if f prime is 0, that means my tangent line is horizontal. So I can look for places on the graph where the tangent line is horizontal, namely things like points like this up here that have a horizontal tangent, or down here that have a horizontal tangent, and those will tell me where my derivative function should be 0. So as an example, let's look at the following graph here, and I want to use it to sketch out what this derivative should look like. So what do I notice first of all? Well, I notice that I have 3 points here that have horizontal tangent lines. I have one here, one up here, and one down here. So on my derivative graph, the graph of f up here, this will be the graph of f prime down here, I should have 3 points where that graph is 0, or where it crosses the x-axis. So it should cross here, here, and here. Now what do I notice out here to the side? Well, out here, my tangent lines have a negative slope. The graph is going down as I go to the right, so I have a negative slope there, which means my function should be negative in this range. I can go through the rest by marking the same thing. In this part here, it should be positive. This part here should be negative, and this part over here on the end should be positive again. And I also notice that somewhere in here, right out where I marked those points, these tangent lines sort of get to a steepest point and then start shallowing out again, right? So I come in really, really steep in here from the far left. I hit a point here where I have 0 slope. My slope is sort of increasing up to here. I hit a point here where I have the maximum possible slope, and then the line starts to flatten out again, so it can get back to 0 up here at the top. Let's see the other way. Now my slope is going down. It's getting steep in the negative direction. I get to some steepest negative slope, and then I start shallowing out again to flatten out here at 0. And I take off, getting more and more steep in the positive direction, going that way. So if you sketch out all those bits together, you're going to have that there should be some sort of maximum point right around here, and some sort of minimum point right around here. Piecing all this together, we'll get a graph that looks something like up here to a max, down through this point, hit that minimum, up through this point, and then take off. And that will be the graph of f prime that I can sort of piece together just based on what this graph looks like. Looking at the slopes, where they're positive, negative, where they're getting bigger and getting smaller, and how it all comes together can give me an idea what this graph should look like. The big things to be able to pick out here should be places where the derivative is 0, where you have horizontal tangents, and knowing whether it is positive or negative based on whether you have slopes that are positive or negative for the tangent lines at those points.